In this video, we're going to talk about something called the 5-number summary. This is going to be based on the quartiles we learned about in the previous video, and once we have this 5-number summary, we'll be able to draw a box plot, which is a very convenient graphical way to represent data that you've gotten. So the idea is a 5-number summary because you're going to take all your data points, maybe hundreds, maybe thousands of them, and you're going to represent them by just 5 numbers. And these 5 numbers are supposed to give you a good amount of information about the data set that you can make quick conclusions and decisions based on that without looking at, all thousands of data points. Before we get into that, though, we need to talk about something called the interquartile range. And for that, we need to remind ourselves what the quartiles are. So Q1 is the first quartile, and it is the 25th percentile. So that is, it's the data value where 1/4 of all the data is less than or equal to it. Q2, which is the second quartile, that is the 50th percentile. So it's the data value where half of everything is less than or equal to that data value. That's also the median. And the last one, Q3, is the third quartile, which is the 75th percentile. So if you think about, you have your data here, maybe I'll make it, not really bell-shaped, just kind of whatever data we have here. If we figure out our Q1, let's say it's right here, that means there's 25% of the data less than it. Let's say our Q2 is right here, is another 25%. Our Q3, another 25%. And that means there's 25% to the right as well. So we're breaking up in these quartiles here. If you look at the part that starts at Q1 and goes over to Q3, right? That's the middle area of the data, and that's the middle 50%. So middle 50% of the data. So that means half of all the data is in that range from Q1 to Q3, and half the data is outside of it, quarter all the way to the left and quarter all the way right, but that's the middle half of the data. That is your middle class. You guys have heard of middle class before? And if you wanted to say how wide this was, the interquartile range, the IQR, is you take your third quartile and subtract your first quartile. So that tells you your interquartile range, how wide that middle class is, that middle 50% of your data. Once we have our interquartile range, we're also going to have to calculate these things called the upper and lower fences here. And I'm also going to give you the outlier rule that works specifically when you're doing the 5-number summary. So the lower fence, the way it's calculated, is you start with your first quartile and you go further to the left 1.5 times the interquartile range. So you're starting all the way at Q1 and you go further to the left here, and the amount you go is going to be 1.5 times as far as the middle range was. Now, if you had a wide middle range, and you have to go pretty far over here for this lower fence. Whereas if your middle range, your interquartile range, was a small value, you wouldn't have to go that far over to get your lower fence. But this is the formula for the lower fence. Upper fence is very similar. Upper fence, you start at the right side of Q3, and you go up 1.5 times the interquartile range. So these are our lower fence and our upper fence. These are actually not going to be part of the 5-number summary, but they are related to the 5-number summary. And what it's going to be is these are going to help us figure out outliers. So any data point is an outlier if it is smaller than the lower fence or greater than the upper fence. So you figure out your interquartile range, you figure out your lower fence and upper fence, and these kind of give you the limits for all the data values that are going to be considered kind of normal or usual. And anything that's outside the range between the lower and upper fence, those are too far away, those are too weird, those we're going to classify as outliers. So this is pretty much the only time that we're going to have a hard and fast rule for determining whether something's an outlier. In most situations, it's kind of can be interpreted one way or the other, whether something's truly an outlier or not. But when you're doing the 5-number summary, we are using this rule here. Okay, so now that we have that done, now we can talk about these last two topics here. First off, the 5-number summary is the following. It's min, Q1, Q2, Q3, and max. So the 5 numbers you're going to give to summarize your data set is the minimum value, Q1, the first quartile, Q2, which is also the median, Q3, the third quartile, and then the maximum. So literally you're giving these 5 numbers. You look at all the data set, whatever the smallest value is, that's your min, you give me that number. You look at your whole data set, you calculate your quartiles, you give me Q1, Q2, Q3. Then you look at your whole data set, you look at the biggest value, that's your max, you give me that. These are our 5 numbers. And that is it. That is the 5-number summary. So what you can do when you get used to it, you can take a look at these 5 numbers and start trying to make some conclusions about what's going on in the data. You could say, is Q1 and Q3, is that close to each other or really far apart? That kind of can tell you whether your data is spread out or not. Whether Q2 is in the middle of Q1 and Q3, that can kind of tell you if you're kind of skewed left or right. When you look at your max and min, you can see, are these values so far out there that they might be outlier values? Whereas if the max and the min are both inside of your fences, well then you know there can't be any outliers because you already know the most extreme values you have. So again, the more you use this, the more comfortable you get, the easier it is to make conclusions from it. But there's even a better way of presenting this data. We can go ahead and draw what's called a box plot, and it's going to look like this. And basically, you just have your number line here, and whatever your min value is, you mark that with this whisker at the end of the box. And your max is going to be marked with the other whisker on the other side of the box. Then your 2 ends of your box are your Q1 and your Q3. So the box represents the middle class here. And the line in the middle of the box, that is your Q2, which is also your median. So you could compare that box plot to say, here's another box plot that has the same max and min, but you can see the data is more spread out here. The interquartile range is much wider compared to the first box plot. So again, you can look at these things as long as you understand what these pictures represented. You can get a lot of information, narrower, wider, and so on, information about the data set just from a simple picture like this. There is one thing that you may see occasionally on these. You may see your box plot, but then you may see something like a red X on one side or maybe even both sides. In this case, those red X's, those indicate points that were determined to be outliers using this rule up here. So when I said that this whisker was really the min value, it's not quite exactly the min value. This is the min value that is inside the fences. So if you happen to have any data points that are outside the fences, you would mark those separately as outliers, and you only use the data values that are inside the fences as your box plot whiskers. So keep that in mind. So yeah, this is what a box plot is. Again, you're not going to be having to graph your own box plot by hand. We have software to do that for us. However, I may give you a picture of a box plot and ask you questions about what it's representing. And so you need to understand what all these things mean when you are given a box plot.